Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating.
Welcome back, folks. We're going to do our studies this episode on the Section 5 of TEMA, Mechanical Standards. In particular, we will reference the 10th edition and we'll make some allusions to some earlier editions because over time the TEMA editions have changed. So let's take a look at the overall architecture of TEMA. We began with section 1, which is essentially the nomenclature, definitions and terms. And we have section 2, which is the fabrication tolerances. 3 is the fabrication and performance. 4 is the installation, operation, and maintenance. And 5 is, which is what we're focusing on, will be mechanical standards. And 6 is an interesting section called flow-induced vibration. 7 is thermal relations. And 9 is the physical properties. And W is general information. And there's actually quite a lot of good stuff in part W or section 9 to have a look at. And section 10 is called good practices. And then there's an appendix A for tube sheets. This video presentation, we will continue our comparison of TEMA Class R, C, and B designs. In particular, we'll look at gasket material, peripheral gaskets, gasket joint details, tube sheet thickness, expanded joints, tube hole grooving, expansion length into the tube sheet pass partition grooves, clad faced tube sheets, channel and bonnet thickness, channel partition grooves, pipe tap connections, pressure gauge connections, and thermometer gauge connections, followed by stacking of units, and then completing that with end flanges and bolting requirements for each of the different classes. Part 6 has to do with gaskets, and there are differences between the classes for gasket materials, which is found in 6.2. For one thing, metal jacketed or solid metal gaskets are required for internal floating head joints. They're required if one is equal to or greater than 300 psi G. It's required for all hydrocarbons. Now, all these rules also apply for Class C, but there's a couple extra things here. So one is allowed to use sheet gaskets provided that they're for external joints, that the pressure is equal to or less than 300 psi G, and it's limited by the temperature of the sheet gasket material. And the last thing, it's also limited by the corrosivity, and so you have to make sure your fluids you're using are compatible with those type of gaskets. And for Class B, follow all of the rules for Class C. 3.1 peripheral gaskets. There are some differences in this section as well. The gasket thickness and nominal shell diameter must be follow this equation. So the gasket thickness of 3/8 of an inch is required for a nominal shell diameter of equal to or less than 23 inches. The other rule is if you have a 24-inch larger than 24 inch or equal, then half-inch gaskets required. At last, you follow the same rules for Class R for Class C, but Class B has a few deviations. You follow the Class R rules, but there's an additional one. Full face gasket is required for cast iron flanges. 6.5 gasket joint details. So for Class R, only confined gaskets are allowed, and solid metal retaining elements are required to prevent the radial leak path. And the reason why they do it is to prevent, gasket extrusion, and issues to prevent also blowout, which can be catastrophic in a refinery setting. And if you want to see some more information, you can go to take a look at figures RCB 6.5 and F3 for some details. But for Class C, you can use confined or unconfined gaskets. And the rules for Class C also apply to Class B. I'm just going to bring you to a couple things here. So that's the one I just showed you there on the bottom left side. That's an example of a confined gasket that prevents extrusion, prevents blowout. And here's another one where we have a shoulder on a gasket or a tube sheet, for example, and you can see it shown right about here. There's that shoulder. Third one is a unconfined gasket. That would be an example. Would be a flat face gasket. And the most common type is, flange you see in a lot of refineries is an example of a confined gasket because the gasket material's here and it's being confined by the bolt. Minimum thickness of tube sheets, there are a number of rules. And for beginning with Class R, the tube sheet must always be at least 3/4 of an inch thick. Secondly, the tube sheet minus the corrosion allowance must be equal to or greater than the outside diameter of the tube. Now there's some relationships between thickness and tube OD. There's some formulas for Class C. The first one is the tube sheet must be at least 3/4 of the O times the thickness or the OD of the tube for 1-inch tubes. Secondly, for 1.25-inch tubes, then the formula for the thickness of the tube sheet is 7/8 times the OD. And for 1.5-inch tubes, then you use 1 times the OD and thickness as a minimum. And for 2-inch tubes, which is you would need to follow the formula of a 1.25 times the OD of the tube. And all of the rules for Class C apply to Class B. 7.24, there are requirements for tube hole grooving. And we have an image down there of a typical grooving requirement. So for Class R, if the tube is 5/8 of an inch or greater, then the tube holes must be machined with annular grooves. For Class C, the same rules apply, but there are some exceptions. Okay, so if the design, it's required only if also if the design pressure is 300 psi G, and the design temperature is greater than 300 Fahrenheit. And for Class B, just follow the rules of Class R. Specific rules for expansion length into the tube sheet. I mean, these are the minimum requirements, and they're found in 7.311. And in TEMA R, the formula is the lesser of at least greater than 2 inches, or the thickness of the tube sheet minus 1/8 of an inch. And for Class C, we have it either 2 inches or 2 times the tube OD. And the rules for Class B are the same for Class R. For tube sheet pass partition grooves, the rule is for Class R, it must be 3/16 of an inch deep grooves are required. Class C has some different rules. They say if it's greater than 300 psi G, then 3/16 inch deep grooves are required, or other to keep the gasket into place. So there's a little bit of flexibility there. And Class B, it's just follow Class C. 6 clad faced tube sheets. If for Class R, you must have at least a 5/16 inch clad thickness when the tubes are expanded only. And that's on the tube side of the tube sheet. And the rule is slightly different. You use for Class C, you use 3/16 instead of 5/16 of an inch. And the rules for Class R apply to Class B. 9.1, that's the channel and bonnet thickness. For Class R, you need to follow the code formula, and the code formula, we introduced that in the last video. That's the ASME Boiler Pressure Vessel Code Section 8 Division 1 plus the corrosion allowance. And also one has to go and look at table R 3.13 and look at the minimum shell thickness on that table, and you have to meet it or exceed it. So it's that relationship. A Class C has the same basic equation but the code formula plus the corrosion allowance, but in this case you follow table CB 3.13 instead of table R. And again, it makes sense that Class C, for Class B, you follow the same requirements as Class C. Channel partition grooves. Channel covers shall be provided with approximately 3/16 of an inch deep grooves for pass partitions. I should probably note that in clad or applied facings, all surfaces exposed to the fluid, including the gasket seating faces, shall have 1/8 of an inch. That applies across the board for C and B, the 1/8, the cladding requirements. Now, for Class C, the difference really is between C and R is that the rules only apply for pressures that are greater than 300 psi. Channel covers shall be provided with approximately, a 3/16 inch groove required, or it allows you to give some flexibility or a suitable means of holding the gasket into place. And the rules for Class C apply to Class B. Interesting one that I've seen people get caught with when converting from a class B or placing an exchanger with that was a class B or a C with a class R. It's the pipe tap connections, believe it or not. So if you follow the rules exactly with the type class R design, then 600-pound couplings or equal are required. And the second rule, which is, good engineering practice, is that it must be the same material as the connection. And alternative materials can be used if, gulling is a problem. Class C couplings require 3000 psi couplings are equal, whereas Class B has the same requirement as C, but they're very specific. They want the same material as the connection. In part 10.32 on pressure gauge connections. If the nozzle is equal or greater than 2 inches, then 1¾ inch minimum MPS pressure gauge connection is required. And there is a paragraph called 10.4, and we're going to review it in the next slide, but it's about, stacked units. So they're basically saying, if you look at 10.4, they say pressure gauge may be omitted if they're, in series, which to me means stacked. And Class C, it just says connection specified by the purchaser, so it doesn't get into that. But it refers to paragraph C 10.4, which is the part on stacked units or units in series. And they're saying you could admit that the pressure gauge requirement altogether. So now for Class B, you would follow the same rules as R, except you can use up down to a 1/2 inch connection rather than 3/4. But I've never seen that. But well, in the refinery, definitely not. 3 thermometer gauge connections. If the connection is 4 inch or greater, then they require a minimum 1 inch connection, NPSH for thermal gauge. They also said refer to 10.4, which is the rules regarding in-series exchanges are stacked. And basically it allows you to, reduce the number of thermal gauges, for a congested area. Connections may be specified for the purchaser for Class C. But they also say, look at the notes for 10.4 for thermometer requirements if the unit is stacked. So they're basically saying you don't need to have two, on both nozzles. One is sufficient. And basically, the rules for Class B apply for Class R. Or we alluded to the connections early. I'm going to start with talking about Class C. For some reasons here. So intermediate flange nozzles shall be flat face or raised face. So they allow that to happen. And then they say pressure and gauge thermometer connections may be omitted if on mating flanges. And so we follow the same rules for Class R as Class C. But there's another note here. Bolting of mating flanges shall be removable without removing the exchanger. And that's a particular case that's quite important so that you can service or replace a unit without having to take the entire system apart. In the other units for Class C and B, there is no such requirement. Except for Class B, where it actually says refer to that one. So Class C doesn't have this bolting issue. Is end flanges and bolting. For Class R, it says that it must be a minimum of 3/4 of an inch in size, and I put the metric in there. And it must be less than 1 inch. If it's less than 1 inch in size, then you use a coarse threaded series, equal or less than 1 inch. And if it's greater than 1 inch, then you need to use an H8 pitch thread. And for class C, you got to be at least a half of an inch, or equal or greater than half an inch, or an M12 bolt size. And if it's less than that bolt size, then checks are required to prevent bolt stress, because when you get really small bolts, they can easily be over torqued. Now, Class B says, if you're 5/8 of an inch or greater, an M16 is required for the Class.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.